Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the battery connections and why the batteries are working in a DC supply, not in a AC. So normally, the battery, in the sense which converts the chemical energy to a electrical energy, and vice versa, electrical energy to chemical energy. So in the sense it will stores a DC voltage and replicates to the load as a DC voltage. So it requires a DC supply for charging and discharging activities. So the connections, in the sense how the battery is connected with the charger and loads, and what will happen if we connect a battery with a AC source. In the sense, if we connect a battery with a AC source instead of using DC, in the sense automatically the battery cannot be stored, which means the energy cannot be stored in a AC supply, because the AC, in the sense the frequency of this AC supply will get fluctuated, which means it will goes from a positive half to say negative half of the cycle. And also the DC, in the sense is a steady state, there is no frequency in the DC supply. For example, if we connect a battery with a AC source, means normally in our home we are using 230-volt AC supply. If we connect with that AC source, means automatically the battery will blows to a exploding condition, which means it will cause a risk and high major injuries and hazardous fires also. The reason is that the AC supply has a frequency, that is the direction and the magnitude of the AC supply changes with a multiple time within a second. The battery can charge in a first half of the cycle, and the second half of the cycle the battery will get discharged, and this will continuously goes up to 50 to 60 times within a second. So charging and discharging will happen within a second, and heat will be produced in your battery and automatically, and the battery will explodes. So the average voltage or current in a one cycle, if we connect a battery with a AC supply, the average current and the voltage of the one cycle will be zero. Next, connection of a battery. So a battery should be connected in a series or a parallel or a combination of both series and parallel connections with the DC supply. So coming up to the series connected batteries. Series connection, in the sense multiple of batteries are connected one by one, which means uh, the battery, for example, if one battery positive terminal which is connected with the negative terminal of another battery, and that another battery's positive terminal will be connected to the another battery of the negative. So likewise it will goes in a order way. Here the overall EMF of the battery is the algebraic sum of the individual cells, which means the uh, total EMF or a voltage is equal to the all the counting of all the individual cells. So the discharged current will not exceed the individual cells value. This is the formula for your voltage. In here, as I said, the voltage in the EMF or induced voltage, uh, the total voltage is equal to the sum of all the individual voltages. Then similarly, the internal resistance, which means the voltage drop in the each cell, that is your internal resistance, causes the voltage drop. The internal resistance of the battery will be equal to the sum of the internal resistance of the individuals, which means the total internal resistance is equal to the sum of the individual internal resistance. This is the connections of your series connected batteries. Then advantage, the wiring batteries in a series provide a higher system voltage resulting in a lower system current. So your voltage can be increased while connecting in a series connection, and also the current which takes while using this series connection will be very much lesser than comparing with the parallel connections. Them if we require a very less current means automatically our installation cost will get reduced, like the type of wires or connections which we are using, it will be get reduced. Then main disadvantages: if we connected a battery system in a series, the converter is required to achieve a low voltage, because easily we can achieve a higher voltage when we are connecting in a series, but in order to maintain this higher level voltage to a lower level voltage, for that we need to have a converter or a charger kind of thing. Then the series connection is a chained connection. If any of the damage or broken happen between this chain means automatically our circuit will be in an incomplete condition. So uh, further there will be no more working in the series connected batteries. So we need to replace that individual battery. Then only we can restore the system. Next, this is the connection of your series connected batteries. In here, as I said, each of the batteries are individual batteries are chainly connected with one another. Like coming starting with the positive terminal, which is your main terminal, and the negative of first cell is connected with the positive of second cell. Then the negative of second cell is connected with the positive of third cell. Likewise, it is going in a order chained condition. This is the example of your series connected batteries. So in series connected batteries, the individual the total voltage is equal to the sum of the individual voltage. So in the sense, each 12 volt into 4 batteries we are connected, so into 4, total 48 volt we are getting as a output. In here the current which taken, it will be uh, constant or lesser than the rated current level. Next is your parallel connected system. So parallel connected in the sense, when a positive terminal of all the cells and the negative terminal of all the cell are connected together, which means all the positive will be collected and connected with one side, and all the negative will be collected and connected with the other side. It will makes a two parallel line, that is your parallel connection. If EMF of each cell is identical, then the EMF of the battery combined by the number of cells connected in a parallel is equal to the EMF of each cell, which means in a parallel connection, the total number of voltage will be same. The number of voltage, for example, saying individual battery voltage is 12 volt means for a parallel connection, the total voltage will be only 12 volt, but the current or the ampere hour will get increased. Let's say the current delivered by the current battery is sum of a current delivered by the individual cells. So here the battery voltage will be constant and the current will get increased, which means the ampere hour will get increased. So in a parallel connection, the voltage remains same and the ampere hour of the battery will get increased for each connections. Next is the advantage. The main advantage in the sense, if the any of the battery get uh, damaged or not working or fails means, that individual batteries can be separated and remaining system will get operated, which means the system will not disturb if any of the individual batteries get failure, means our system will be in a healthy condition. Second thing is that connecting batteries in a parallel results in a higher current draw. This indicates the we require a very much thicker cables for connecting this uh, parallel connection. This is the main drawback of your parallel connection. This is the example of your parallel connection. Here the parallel connection, all the positive terminal are connected together and taken in a single line, and all the negative terminal are connected together and taken in a single line. So in here the voltage will remains constant and the current or the ampere hour will get increases when we are connecting in a parallel connection. This is a example of your parallel and series connecting connections, that this will be explained in coming up slides. Then This is the example of your both parallel and a series connection. As I said, in a series connection, two 6 volt battery, when we connect in a series, means it will forms a addition of voltage and forms a 12 volt, but the ampere hour remains constant in a series connection. But in a parallel connection, the voltage will be remains same, and the ampere hour, which means the current rating, will get increases when we are connecting in a parallel connection. Next is your series and parallel combination. In some cases we require both voltage and current in a higher level, like in a higher level larger industries we require both voltage and current. So in that time we will connect a in a combination of series and parallel combinations. So a load requires both voltage and current more than that of individual battery cells. For achieving this required voltage and desired number of batteries or a cell can be combined in a series, and for achieving the load current, the desired number of series connected cell are taken in a parallel combination. So this is how the series and parallel combination works. This is the example of your series parallel and series parallel combinations. First, series in the sense 6 volt battery, two 6 volt batteries are connected in a series, means automatically it will form 12 volt, because the voltage get increased and the ampere hour will be constant. In a parallel connections, two 12 volt batteries, when we connected in a parallel, means automatically the voltage of your battery will be remain same, and the ampere hour of your battery will get increases. So next is your series parallel connections. Series parallel connections, uh, two sets of 6 volt battery which is connected in series and taken in a combination of parallel. By this we can achieve the desired voltage and the current ratings. So this is the example of your series parallel connections. Just have a look in this, how they are connected and how the voltage gets splitted. In here the series parallel, just see the slide. Series parallel connection, 24 volt series parallel. Here 4 batteries, 12 volt batteries are used, that is converted into a 24 volt when we connect in a series parallel combination, and the ampere hour of this battery will get increased. For example, if we said for each single battery we have a 10 ampere hour, means automatically if we connect us in a series parallel combination, means it will get increased to a 40 ampere hour into a 24 volt battery. Next slide we will have a deep view on a calculation of this battery combinations. Have a nice day. நன்றி, வணக்கம்.